and it would be just simple knowing about the language, how it works, what are the data types and functions, and any type of classes and object-oriented programming in the Dart. And the main thing is, in this session, we would be only covering about the basics of Dart and not touching very high topics. And also, if you have done previous lectures, previous sessions, where we covered about working and making UI with Flutter using the Dart language, we will also cover about those things, that how we are using different tags and all, and different classes. There are widgets, slitless widgets, and stateful widgets. How we were using scaffolds and rows and columns. We will have another session for that. In today's session, we would start with Flutter. And so I guess I should start by telling you what is Dart language and how can you install it. If you want, you can directly install the Flutter SDK or Dart SDK from the internet. Another best way is you can use Control Shift and P in your VS Code. It would open some kind of this prompt, and you can see here's Flutter. I can also type Flutter. When I type Flutter, there's a new project. When I click on this, it will prompt me to build a project. But if you haven't installed the Flutter SDK, you will be prompted to download the SDK and then uh, locate it. So you can install Dart directly from that side. This is one way, and the other way is to install the Dart SDK directly from the website. So I'll make a file. Let me open a folder first of all. Okay, so I have made this test folder, and I'll make this file, and the extension is .dart extension, and after this is saved. Now, working with Dart, first of all, we need to know it's very similar to how we use C or other languages, where there's a main function, which is the main key point entering the file. Whenever we want to run anything, when we run the file, the main function is the first thing that will run. So we need to make sure that we have a main function in our file, and everything else is called inside it. So let's start by, I guess, printing something to the console and trying the language. And it is, since I said it is similar to C, because we need semicolons to tell the compiler that the line has ended. And for learning this, we can just simply use Dart and then tell the file name. So it prints to the console. And these are the basic things, and you can start from this by printing. Now, a few things about the language are that the language is optionally typed, and I'll explain this what I mean by optionally typed. There are two type categories generally, which is statically typed or dynamically typed. Statically typed languages are like C, where you need to specifically tell that the variable should be of int, Boolean, or some other kind of data type. We need to explicitly tell at the initialization process or where we are declaring the variable name. And dynamically typed languages are like Python, where you need not to tell anything about the variable, and you can change its data type throughout its lifetime of the program. So these are two. The Dart sits in between both. It has all these C features and also the Python features. We do not generally recommend using the Python features, or actually, what I would say, like to say, is dynamically typed features. You can use them, or a, a few things we'll discover in a moment. First of all, let's say how I'll create this num. So I've created this num using an int variable int tag. So this tells that we are using an int, which is a data type. Another data type that we have is double, and let's say some price is there. You can tell this. So it's by a decimal. So we can hover it and tell this is a double, and this is a int. So these are the basic data types. We have also Boolean and all. You can check these out on your own. A few mentions that I would like to do is, first of all, that let's say we are using, these are some few keywords that we have are var and let. I'll talk about var first. Let's say I want to define a string. Let's say I did var and then string. So this name is storing a variable which is a string. And I have not explicitly defined that it is a string or it's a num. Let's say I change it to 10 and then let's over it and we can see that it's an int. So this means that it can dynamically infer from the variable type that what the data type should be of this variable name. These are the things that can be these are the features which make the Dart dynamically typed, and using int and these double with a variable name make them statically typed. Now, a few things that I guess we should know is are dynamics. This is also a data type. Let's say anything, we can say this because it can store anything. Let's say if we are storing a string, this is just a string name, nothing else. So this dynamic is not making any data type. We can switch anything, this name from let's say this to this, and it is not giving us any error. But if I change the name's value from a name or from a number to a string, let's say 3, now this would provide us an error that it was an int, but it is trying to be a string. So we cannot change the data type of a variable which is already defined in any type. If this is all we have already predefined the data type of this num, so we should not do this. But let's try. If I try to make it a double, so it is also providing us an error that it is trying to be a double, but it is an int. So we cannot change this. And this is the same story for this way that it can infer from the runtime that what is the data type of this name, and then assign that variable that data type, and we cannot change the data type. But using dynamic, we can change it during the runtime, and there's no not specific data type assigned to this anything variable. But this is not generally recommended. A better practice is to know what the variable you are using and then use it directly. So I guess these are the very few basic data types there are. We'll cover few more. And one thing that I would like to tell you is we can use null safety in Dart. Generally, what we are given is we cannot use anything which can be a null. Let's say if I defined a string here, let's say I'll make it a string. The thing is that this needs to be capital. Yes. This is a string, and if in future I made this anything variable to be let's say null, I cannot technically do this thing because null cannot be assigned to a string. But if I provide the null safety to this, the error disappears and it can take null value inside it. So this is a feature that Dart does not explicitly allows you to have anything null or nullable inside it. Not only in strings, it can also happen to ints. Let's say I'll use num1 and make it 10. And if I try to assign num1 as a null, so we'll get an error that it is an int and it cannot be assigned a null. But if I add a question mark, it can be made null. So this is the inbuilt feature of Dart, that it cannot, it will not assign a variable null value by default. You have to explicitly tell it that there's a question mark by adding a question mark, that it can be a null in future. So make that data type clear. And a few data types that are, I would say, immutable are final. If we are using a final and let's say some time, we are not changing a time or maybe some price, I would say. So we can do this and let's say 10 and data type, final, int, and price. Oh, it's defined the price already. So this price, you can see this it's an int and we cannot change this value let's say I use price and I'll try to make it 11. This will give us an error that it is a we should make it a non-final and then try to change its value. We cannot change its value. And also there's a const, which is constant at the compile time. That if I define some in num2, that is 10. So this would be constant at compile time. I would not be changing its value anytime. So these are some things, and as we have defined that these are also, we can also create, how can we create nullables? A few that are late, late and let's say late, final, and then a string. So what we are doing here, it is we are telling the compiler that it is a variable that I'm defining right now, but I'll be adding its value later on in the future. But it's like a promise that I'll be defining its value. It will not be a null thing. But currently you just define it with something null or just define it, but I'll add the value in future. So this is a thing that also allows that uh, you can say just book a variable name and in future you work it whatever you want to store into that. Let's say you are using it for fetching some data and you have defined the few variables that would store your data that is getting from the database. You are getting something from database and then storing them in the variables, and you do not want to initialize them from some garbage value, or you do not want to store some zeros or -1 initially. So you can use late, and whenever the data is arrived, you can store them into the variables. I'll add question mark from the error and then comment it out. Now I'll add cannot change. This is done. I'll comment everything. So these are done. So we have uh, clear understanding about print, how print is working. We'll cover about when we are in the strings part. We have known that there's an int, we can use double. Var is also there that can infer from the value assigned that what the data type should be. We know that there's a string, how can we define strings? And how can we use dynamic as well? We have used dynamic, and we know that dynamic can change its value during the runtime. We know that how can we create nullables in Dart, and then how final and const works, that they cannot change their value. Final is matlab the final value doesn't change any at all, and the const value is constant at the compile time. And late is for when we want to make a variable but want to initialize its value later. Few more things, I guess. I'll make a nullable variable. Let's say I'll make a num and do this. And let's say I'll tell you about type promotion. What actually happens is if you want to access, let's say if you want to access this num variable inside a if block, and let's say a 9, I'm using a 9, or maybe some true value. So technically, the problem becomes that if we are using a null variable and a nullable variable, and we are not checking its value before doing some operation inside it, we can have a few errors. Maybe I was doing a multiplication with this, let's say now. Now this would be an error because we have not checked that this variable is null or not. It can store null, it can even store 10 if I do 10. So this is fine, this is not a problem. Now there's no error because the language is understanding that we have assigned a value. It is not null, but let's say you are fetching something from a database and the value didn't arrive. And you have provided a nullable variable which is storing that data and the data has not come. So the variable is null, and you are performing some operation that you are maybe multiplying it by 100. So what is it going to multiply with? It is not going to multiply null with 100. So we use the type promotion where we check this num is not null before accessing it. Now, if the value is even null, we will have no problem in using it inside this. Let's say I'm not assigning this. This will check this if it's a null or not. After it's not a null, it will then only run this part and not otherwise. So this is the type safety you can say technically in Dart, that it will not run this if block. We are already checking that it is a null or not, or you can use question marks and all. We'll discover that later on, that how can you use type safety in a single line rather than using an if else. But this is also a part that if you want to, let's say, even print this part, you were trying to print this num, but if it was a null, that you would not be able to do this directly. Let's say if I just use true normally, you'll see we'll have an error here, and this would be an error as well, that you cannot print a null. So this is this. So I guess the variables part is good enough. We should move to strings, and strings are very special in Dart. First of all, we can define a string using this syntax. We can use single quotes or double quotes, both are fine. There's no issue in using single quote or double quote. And also, yeah, at the time of defining a string, there's a term string interpolation, which is interpolation, in which if you can technically concatenate two strings or put one string inside another. Let's say I'll use hello and use this string with world. Then I can use a dollar mark and then add this string variable to this, and then and let's say I'll try to print this string one, and let's try this out. So you can see we are printing hello world. This second hello world is this. So we are using string interpolation to concatenate these two strings inside each other, and a few more. I'll make another string. We also have raw strings. Let's say if I do this R, this means that the string is raw, and if I write anything, let's say you can see that this part is white, and now this part is only blue. This means that anything inside this, even escape characters, will not work normally. They would be considered as part of a text. Let's say if I was trying to print this string one, what I'll get is hello world and then a blank space using this escape character. When I'm using this string 2, when I'm trying to print this string 2, what I'll get is I'll get normal string, whatever is written inside the string would get printed normally. So you can see there's no change in this. We are printing the exact thing that we have written inside the string. So this is a raw string. Anything, any backslashes we put for escape characters, any string interpolation is not considered. It would be just a raw string. So this is about the strings, and also if we want to write a long string, how can we do so? So we have a multi-string using three single quotes. We can create a multi-line string. You can see this is a multi-line string. If we want to use it for some purpose, we can use this. And let's also see how string concatenation works. So, okay, we'll concatenate the string 1 and string 2. Let's say if I want to do string 1 plus, I can do a plus, then for space, then I'll use string 2. So using this, we can concatenate two strings, string 1 and string 2. And as well as there are a few functions that you would be using generally in your daily Flutter usage or your Dart usage, which are using some functions which are, let's say, I'll tell you, let's say we are using a split function. So using the split function, I can tell it that where to split the string. So technically what it does is it returns us a I'll show you. So in this, so you can see that it has combined two strings. First of all, string 4 is combined, and after that, we are splitting it based upon the empty spaces. So this part is deleted, and we have a separate string that the hello is different, then the string is different. In this, string 2, okay, both strings are separated, and you can see that we are getting a list. I'll talk about the list in later on. You can see that the string one's hello world is different, are separated. That hello world, these are separated, and then the string two's hello, this dollar string, and then the backslash n are printed out in a separated. So this means that it separates based upon the white space, a single white space. If I do two white spaces, if it finds a two white space, it will split the string based upon that. So currently we are only using the single white space. So this is this, and so we have currently discussed about all the normal data types and as well as the strings and a few uh, important functions that we need to know about the string. Another thing that we have is collections. Collections consist of lists, sets, maps, and these are the core collection types. And we use them like, let's say, I'll show a list, and then I'll provide a data type, and then I'll provide a name, let's say numbers. And I can use them by using one, two, three, four. You can see that I provided a collection. I'm using a list collection. Then the data type is int and the name. And then for list, we use square brackets. A similar is set. And let's say I'll use string, let's say, and name. So we use key value pair keys in this. Alice, let's say Alice, Bob are the quite famous names. So let's say I'm using this and it stores them in an ordered way. Unique elements are stored in an order, but it is not guaranteed actually. And the list is technically what I wanted to tell you. Yes, it's a immutable list, and you can add numbers. Technically, it's not something that you cannot add. Let's say all I'll use is number dot add, and let's say I wanted to add 5. So you can add a number 5, and the same goes for the names. You can add a key name dot add, and then let's say Charlie ABC. Yes, yes. This we can add this as well as, and then we have a map which stores things in a key value pair. Let's say I'll use a map for an intent age, age and weight, or let's say HW for height and weight, and it's a curly braces, and then we can store, let's say, 1 with 2, and then 2 with 3. So technically, these two and this two are different. These are the first values are the keys, and the second are the values. So let's say I want to access the 1, so I'll get a 2, and when I'll enter a 2, I'll get a 3. So this is this, and I can even change the value because these are immutable. I can change the value of this 3 or the value of this key 2 to be an 8. This can be done as well. And since these are collections, we can iterate over them as well. Let's say I'll use a for, and we can use a var, say value in, and let's say number, and we can print these. Print, and the number is, and then you use the interpolation, and then use this values. And when I run this, you can see that we are printing these numbers using this iteration part. You can also use for ins and for each, which are also these indexed loops, and a few functions that we need to know about these collections are, which are very important. are map, spread operators, and also using if inside these. I'll go over them one by one. Say var. Let's say I want to get a list, and I'll use numbers dot map, and then I'll provide, let's say, n. What I need to do to this n is I'll multiply this n by 10, and then come after doing this whole operation to list. So this is this, and let's try to print this list. As you can see that the numbers 1, 2, 3, 4, 5 are multiplied by 10 and are in a form of a list. So what we did is map function uses all the values in that particular collection. It iterates over all the values in that particular collection and takes them as a value in this parameter n, or you can use it as x, whatever you like. And we are providing a small function here, arrow function, which is taking an argument and then providing some. This is technically you can also provide and return, but it is not required. In function terms, you return something, but in this part, the calculation is the thing that is being returned. And after the multiplication is done, we are converting the whole result to a list using this function so that it can be printed easily. And also, one thing that we can do is a similar thing is to use if and spread operators inside this. I'll show how. Say use 0 if this number is not empty, and I'll add numbers. Let's try run and see. So you can see that we have added a 0, and for the rest numbers, we are using something this. I'll explain how we are working on this. That we can use if else in this part, not if else, if for some condition, that if that condition is true, then we are going to use that number. What we are doing is very similar to a map. We are taking each number at a time. We are checking if the number is not empty, if that list is not empty. If that list is not empty, that we are spreading that numbers list. What spreader does it takes the value of these numbers and it arranges them in a list. So what we can say is that we had 0 and we had a list of 1, 2, 3, 4, and 5. What it did is it checked that this list was empty or not, and then it inserted that to this new list. So this is a way we use spread operators to add a old variable to a new collection variable. So this is the format for doing this. So okay, we have covered this concept. Now the next thing is for control flow. In control flow, we have if, else, for loops, which we have already discussed a little bit, then while, and then switch cases as well. And we also have continue statements and also the break statements, which are given in default, but we'll discuss them later. If is normally just we have seen that if we provide some condition, let's say something which would result as a true, it would run. And there's also an else. If that condition was false, if it was false, then else will run. And we also have an else if, let's say true. So we can use this if else if ladder, which is generally called an else if else if ladder, and we can also use the nested if else. That inside an if we can also use an if or else. So this is one thing. Then the for loops that we have seen. For loops are similar. We use a where I, which is let's say a 0, then a semicolon, and the limit, let's say it's an 8, and then I plus plus, and then we do some operation, let's say print or something that for that I. This is this using the for loops. We can also use this for iterating over the variables that we have seen here, that where we use this iteration procedure for iterating over a collection. We can use the while similarly. It does not have a initialization part or a incrementation part. We have to uh, use it on our own. Let's say I use a variable j, but I need to define j beforehand. And let's say same procedure, we have to do this j, and then we have to also handle the incrementation part from our own perspective. So this is for the while, and switch case is for we take an argument. Let's say I'll take some string, let's say some string one or something, and then based upon that string, we check that if that string was, let's say, A, B, C, D, and based upon that, we do something. Let's say if I want to print it or I want to do something else, and then another case, let's say if that string was A, X, Y, then I'll do something else. And this works same for the numbers as well. And we can also return some things if we want to. And also, a mentioning thing is we need to provide break after every switch case, because else it would start running. Let's say if this case was we had a string, the string one had a value of AXY. After this case is executed, all the other cases which are beneath this would also start execution. Uh, to stop that case, we need to apply break after every case. And there's also a default. Let's say if nothing was running, we can use this to provide. If it's very similar to how we were using if else. This is the else in the if else if part, that if nothing was there, then what would you do? So it's better for, let's say, if we have not handled some case, or maybe we need to put that into an error part. So this we have learned about the control flows, and also we have break and continue for loops. Let's say if I wanted to continue upon, let's say if my j was 5, then I wanted to continue. And if my j became 7, let's say 7, then I'll break out of this. We can also use break. So break will prematurely exit out of the loop, and the control flow would move out of the this brackets, meaning this would start executing the next thing in the line. Now we have covered these so far. I'll comment this for the errors. Okay. So now we need to move out of this loop, main function. We'll be learning about how functions and how we can use them. Functions we can use about using void, or maybe let's say if I wanted a function using this when we are telling this, let's say void or maybe int, or maybe we are telling it to be a string. What it is going to do is, let's say I'll also define a function. When I do this, it is telling the compiler that the function which I'll be defining would be returning some data type. And that data type would be, let's say if I had a void, that means this function 2 would not return anything. That I would not be expecting anything from it to be returned. In this function 1, it would be expecting a int value to be returned. So when I return at the end, it should be a int value. And when I'll return from this simple function, then it needs to be a string. It would be a string, it cannot be a int, and it cannot be a string or a boolean. Let's take an example of, let's say, an add function. I'll make an add function. And how does we pass the arguments? This is the way you define the variables, and then you can return them like this. So this would do the operation and return them. A short way of writing the functions that we saw in the map function is like this. So this is also a shorthand notation, and we need not to provide a return statement. These are for single line functions. We need not to provide a return. This a plus b is automatically returned by this function. We also have a concept of optional and the required arguments. How we use them? Let's say if I provide a function of, let's say, a hello function, and I'll take a name, and also let's say I provided a optional argument of, let's say, age, which is by default, let's say, something to a 0. So what we are doing here is, let's say I'll also print this name, and I'll return the name. So what we are doing here is we are making a function that would be returning a string, as we did here, and then we are taking a variable argument name, and then we are providing some argument in a square brackets. This argument is an optional argument. When we call this function, we can technically, let's say I'll first of all call this add function just to showcase. I need to provide two things. I'll call this add, and then I'll tell it 8 and 9. Let's run this. And as we can see that the answer is 17. So this is true. If I try to not, let's say I do not provide the second argument, and let's try to run this, you can see that we get an error that few positional arguments, two were required and one was given. So this is the thing. But let's say this is the same procedure in this string, that we are providing the name and the age, and we are returning the name. And there are two positional arguments, but let's say what happens when we pass only one. So I'll call this name, and then I'll tell I'll just provide the name. When I run this, you can see that the name is printed two times because we are printing here and here. What is happening is this age is optional. If I want to provide it, I can provide it. Let's say I'll provide a 9. So it run again because there is no error. It's an optional argument. The language understands that if the argument is not passed, there's no problem. If it is passed, then it takes that value that is provided. And what I'm doing here is I'm also providing a default argument, which is a 0. And if nothing is passed, the ages will be 0. And if you want to do this, you can do, if you even you can remove this part, but technically it is recommended to use this because it gives you unnecessary errors. That there's a default value which is an optional. If you provide it, that's good. If you're not providing it, that's also fine. Another part of this is using required arguments. For required arguments, we use curly braces, and need to remove this. In curly braces, we also provide a required name. Yes, this. So what happens here is we are providing a required flag and then telling the system, the function or the compiler, that this name and the age are required. If anyone doesn't enter them, then we'll show an error that these are required. So this name part is required and the string part was not required, so we can skip this. Let's say if I've also provided required here string, remove the default value. Let's say now here I am not providing the age, and let's try to run this. So you can see that required field is generally necessary, but it also uses a default value. By default, it's empty, so that it is not a error on the user side every time if we are using a required. But this technically enforces the function where it is being called to pass a value before it is being used inside this. So moving on to higher order functions. In higher order function, it's just we provide a function to a function that can be called. I'll provide an example. Say void higher, and this function is taking an, let's say, int twice, and this would be a function, and then int function int, and let's say an f, and this f x is this, then when then provide an int x in this, and then this one should be here. This five, and then this int. So what we are doing here is it's a bit complicated, but it is we are using this twice function. It is taking a five and a function, and then that function is being called over that x. And what it is going to do is it's first of all going to increment this. We are providing an x to this. So the five is provided to this function. It makes it six and returns it to this. And then again we are doing this and we are providing the six to this increment function, and it is making it to the 7. If we provided it as 5, it produces 7. Uncomment it. So this is one thing, and another higher concept is closure, which captures the lexical scoped variables. The return function actually retains the access to the variable that was provided. I'll give a example function. Say an adder function I know, which is an add by and return by, then I'll do I plus add by. And then how this function is used, let's say I'll use a var, and then let's say I'll do a add variable, and I'll call this adder function by, let's say I'll providing my 5, and then I'll print this uh, add by providing it up 3. So what it is actually doing, it is returning a function. So what I did is I provided a 5. This is giving a error because I'm not inside the main loop, but ignoring that fact, it is returning a function, as you can see, which when provided a value, it will add the value which was previously given when this adder function was called. When I called this adder function with a 5, it provided me with a function, which function, when called with a value, would add that number with that 5. So if I run this, I'll get an 8. So I'll run this, also make them here. Let's say I run this. You can see that I got an 8 in the last because of this. I called 5 and then 3. So first of all, the value was 5 for this add by was 5, and the function was returned, which function was called with a 3, and the 3 was added with the 5. So this is the part for the normal classical programming in the Dart. Now we'll move to classes and object oriented, and then we'll also discuss about a few different types, which are enums, type defs, and generics. And then also, I guess exceptions are left. And the main thing is we'll touch about asynchronous programming as well. So we should start with the classes. How to define a class, first of all. A class, and then let's say human, and with the curly braces. And we can provide data types in this, how we did earlier. And an interesting thing that we need to know about this in this is that we used when we were making the calculator project earlier, where we used underscore output variable. These variables are private variables inside a class, and these cannot be accessed by anything else outside that class. So this underscore output is only inside the class, and it will be only used by this class functions or the methods that are provided inside this class, and anything else outside this class will not be able to access them. So let's also make a constructor. How a constructor is made by the same name. We use the same name. And then we provide this. This is for context, that using the current variables that are passed to this and to what it needs to assign them. This dot output. So using this, we are making a constructor. We can pass the values whenever we call a, let's say I'll call a human class. Then I can provide the name and then also some output. So this will create a class variable and provide it to us. We can use them. Let's say if I want to store it to some variable. So you can see that it would provide me a class where the name of this is blank and the output is 9. So this is this, and we can also create the functions inside this, which are, let's say, um, any function that you want, maybe a int number and then a function. However you like it, you can define them, functions. Also, different type of constructors are there. We can have a named constructor with, let's say, an additional expressive way to construct these objects. Maybe a particular variable we need to define, or we need a few variables that if we are only passing the name and we are not passing the age. Let's say in this one, we can also have that if we do not pass the output, then also, but we need to also define that what age or sorry, output in this part should be. Say we need to provide this output as this, and we'll also do it, let's say, without output. So whenever someone calls this human without output, so what we need only is a name and output is already assigned to 0. We can use this as well. And yes, one more thing, that how we can then change the values of these internal variables is using set function, setter and getters, which are provided to us by the classes function. Let's say output, and then the int value is provided, and what we do is use the output, provided the value. So using this set function, we can change this value of this output from outside this class using this setter and getter. Then also interesting part is inheritance that we need to know. Inheritance is technically when a child class inherits the properties of its parent class, that there are a few functions in the parent class, and a child class is inheriting the parent class, then the child class will also be able to access the parent class functions as well as the functions that would be defined inside it as well. So if I make a class of maybe animal, and then I'll inherit it, I'll inherit the animal class in this. Let's say string of maybe type of maybe what it is, a mammal or something. What human class can do is it can use the syntax like this extend and then this animal class. So what it has, it anything that is defined in the animal class would be used by the human class as well, and extra functionality can be provided to the human class as well. And any function that is provided inside this, let's say some kind of a age related or maybe a height related question, or a function that we can access, we can use it and change its working by using an override. Okay, I guess remove this. And any function that was defined in the animal class can be changed by the human class for its personal usage. So any human that is defined will have a different meaning of that function that was defined in the animal class. So this is one thing. And another type of classes are abstract classes. These classes are basically building the blueprint of something. Let's say if I had a shape class, or maybe let's say a calculator class, it's a cal. I can predefine a few functions. Let's say a double for maybe add. Then I'll have a few functions. I'm not defining the names. You can define them on your own. The main thing to understand is that I'm not defining how the function is working. I'm only defining what the function name is and what's its data type, or maybe a few how what are the data type of its arguments. What I'll do is when I'll use another class, let's say some I'll use this class and then I'll extend, or we are since we are using an abstract class, I'll use an implements and then this cal. What I need to do now is I need to implement all the functions in that abstract class to implement this. So what I'll do is double and then add function and then int a, int b. So what it is doing is it's using, and also yes, we need to provide an override since it's not the function of this. So what we are doing is that we took a function, created a blueprint of this using this abstract, then implemented that class using another class, and then changed its functions and then implemented them on our own basis. Let's say if I had a class of shapes. So what I can do is I can define perimeter. I can define a function for getting the area. And whenever I implement them using, let's say I implement it using a rectangle class, then a rectangle class would implement this shape class and it can define its own variation of its perimeter and the area class. It for area, the area function for a rectangle and a square would be different. So what we can do is define a main parent class where the functions are available, common functions are available, and other child classes implement those classes and change their functionality based upon what the class needs to do. So these are the few basics of inheritance. Another thing I would like to touch a little bit would be mixins. We define them by this mixins. These are technically we use them for providing a little bit extra functionality or reusable behavior, we can say, without any inheritance. How we use them is by using, let's say, a class, some a that would extend another class that we have already defined. Let's say this human class with, and then with we would use this mixin. Let's say mixin is, let's say, arms, maybe let's say arms, and there's a some function defined here. Let's say a void. A void function is defined here, which is doing something, and I can use this and then define a new function. So this is a constructor, and then I can call this super, and then provide, let's say, if I got some name or some age, let's say, and then I can call this with this parent. So this is a gist of how mixins work with the classes. These just provide a reusable behavior to the classes without using any inheritance. And this is and are used with the with keyword. Now, I guess Here's a few then that enums, let's say color, how we define them is by this red, blue, green. These are enums. Then there's type defs as well. Type def is for, let's say, if I wanted to use something, let's say, long, again and again, I can define it to, let's say, just LL. So whenever I use this LL, it will understand that it was an long. So we need not to use this. Then the last thing is for classes is expect exceptions. If you want to create your own exceptions, let's say my exception, and then I can use implements, and then the parent class is exception. I can create my own exceptions here. Let's say a message and anything. I can use a message here, and I can use the functionality however I like to use it, and provide the particular exception I want to use. And the class that we are using, we can use an override, and the function that we need to actually override is uh, also we need to provide a constructor for this. You can use a constructor and change this constructor. You can use this on your own. That this you can do a this dot message and this dot message, and then provide something. Then override string to string, and then can do exception and then provide this exception. This is a way of using implementing your own special exceptions if you want to like do. The last thing that we need to cover is asynchronous programming. Dart actually uses a keyword which is a future. This is for single asynchronous results. And if you want to have a multiple sequences of asynchronous events, then we use stream. Stream is another keyword. And to access these functions or these parts where the future or streams are used, we use async and await keywords. And also one thing that we need to keep in mind that anytime we are using asynchronous programming, we do not know that the function is successful in working or doing what it was assigned to do or not. So what we need to do is we need to use try catch or then catch error blocks just to make sure that we are not uh, getting into an error, and that error is if that error is uncontrolled, or you can say is not handled properly, then we will get an error continuously. So I'll provide an example for this. Let's say some fetching is going on, and then I'll provide an n, and since it's an I told you async, and then await, then await in future, let's say I'll use delayed, provide duration of milliseconds, let's say 300, and then I'll return this. And so what is happening in this is we are using a future and an int type. Obviously, it's a dynamic here. Then this function fetch, and it is using an async for this part, and we are using an await to call this future dot delete. This is also a future function, which is you can say a asynchronous part, and it is using some duration after this 300 milliseconds. We'll close this function. This is how a simple asynchronous part looks like. And let's say if I want to use stream and int, and let's say a counter, I'll say and again int n. Now this would need async star, and also this stream events are cancelable, that we can cancel them in between if you want to. And for var size 0 size less than equals to this n, then I plus plus. And then the same thing we need to do is this, and also this yield. This is for this to matlab, this is technically for emitting the next value onto the stream, and we can use this for this stream part, and we can also use this stream inside this function, but I guess we need to provide it to a void and not return this, and we can also call this. This is the error for we have not referenced this. We can use this also. This is for asynchronous programming, where we need to provide a data, or maybe we need to fetch from a database, and that database is slow, and we need not to wait. Let's say if the database is providing the answer in 10 seconds, then do not want our UI to freeze up for 10 seconds to wait for the data to arrive and then to show. It is not a good experience for the user. So we use asynchronous part there, that the uh, we'll use this future or stream to get that data. We'll fetch that data, and then after the data is arrived, in the meantime, our app stays functional, and whenever the data is arrived, we can show that to the user. And I guess this sums up the all the basics that we need to know about the Dart language. We can use these basics of these classes, strings, ints and double variables, var, then nullables, then late, final, const, then the control flow part, then the string interpolation, then the splitting function, then collections, use list, string, map, then the iteration part of them, then also how we can use if and spread operators inside the collection, then how we use the control flow, if else if ladder, for loops, while loops, switch cases, then adding a switch cases based upon the value that we are using, the condition here we are providing, also the default. Then also we discussed about these closure functions, then the higher order function, that a function is calling another function, and the functions are there. We have uh, optional parameters, and then the required parameters that we need to provide. Then we studied about the classes, how the class is defined, how we extend classes, how constructors work, how we can override the function of a parent class if it is extending the class, if it is extending its parent class. Then how abstract functions are called, how we can implement those abstract functions and provide different implementations for different classes. Then how mixins work, we can provide additional behavior, uh, or you can say reusable behavior without implementing it again and again. And it is used with this type of a format, that a class extends something with this mixin. And then we look over enums, where we can iterate over this red, blue, green using this color variable. Then we also studied about how can you make your own exceptions if you are using them in a, let's say, a switch case or maybe a if else. You can even use them in your try catch blocks and provide your own exceptions, where this is a format for providing your own exception. And then we at last studied about how asynchronous programming works. We can use future stream and also provide the data type that it would be returning. So this is, I would say, a broader overview of asynchronous programming as well. You can study them in more detail. Uh, the documentation is very good on the Flutter on the Dart website. You can go and explore that. And I guess this sums up the session this session, and this is complete overview of Dart language and its basic data types and everything. So thank you for attending the session, and thank you.